Welcome back to the Grand Solar Minimum channel. Today's paper, titled Contrast Analysis Between the Trajectory of the Planetary System and the Periodicity of Solar Activity. Before I read the conclusion, I'd like to take a couple lines here from the introduction. The movement of planets, solar activity, and global climate change are increasingly being explored. The periodicity of solar activity along the physical mechanism of the changing of the sun is an important topic in solar physics. Now on to the conclusion. In this study, the kinematic index of the heliocentric longitude is developed based on the orbital elements of the planets and is used to investigate the exact position over the planetary system over time. The numerical situation results show a 19.8-year cycle for the planet juncture index and an 11.5-year cycle for planetary systems heliocentric longitude. The use of the periodic rule of the planetary systems movement, a cross-subject research method, is a new way of investigating solar activity. The present study provides two innovations. One is the full consideration of the gravitational interaction among planets, and the other is the simulation of the planet's juncture index heliocentric longitude. Nearly 1,000 data points of the planetary system movement are obtained by numerical simulation. The movement of the planetary system from 1007.8 to 2016.6 AD shows a 49.9-year cycle for orderly orbit and a 129.6-year cycle for disorderly orbit. A double century cycle of about 179.5 years is necessary for orderly orbit or disorderly orbit before realizing the next cycle. This trend is consistent with the solar activity and global climate change. This finding is theoretically valuable for studying solar activity and global climate change. Sharvatova has noted that the same phenomenon can be observed in the orbit of the Sun around the center of the mass of the solar system. Their results reinforce the previous findings by Sharvatova. The comparison between the planet movement and number of sunspots shows that during orderly orbit, the number of sunspots is relatively high, sunspots increase, and shows a high change rate. Meanwhile, during disorderly orbit, the number of sunspots is relatively small, becomes non-existent, and exits the solar system. The number is also unstable with long cycle times with an average range of 11.5 to 14 years. These findings illustrate that the planet movement influences solar activity to some extent. Similar results have been obtained by Sharvatova, studied the orbit of the Sun around the solar system barycenter. 6 protracted solar minimums have been observed since 1000 AD, and these minimums are the Oort minimum of 1040 through 1080 AD, medieval minor minimum 1150 through 1200 AD, Wolf minimum 1270 to 1350 AD, Spore minimum 1430 to 1520 AD, Maunder minimum between 1620 and 1710 AD, and the Dalton minimum 1787 through 1843. The movement of the planetary system is simulated, and the results indicate that the solar minimum and little ice ages correspond to the planetary system's disorderly orbit. Therefore, the planetary system disorderly orbit usually occurs with the protracted solar minimum. The planet's juncture index and heliocentric longitude are two important kinematic indexes of the movement of the planetary system around the solar system's barycenter. The planet juncture index represents the distance between the planetary system's barycenter and the Sun's barycenter. This index also represents the degree of convergence and separation of the planetary system. The planetary system's heliocentric longitude represents the exact location of the planetary system's barycenter relative to the solar system's barycenter. The planetary system's heliocentric longitude also complements the deficiency of a short cycle and provides reference for studying in the next planet juncture index. The movement of planetary system remains consistent with solar activity to some extent. Thus, analyzing the periodic trends in the planet movement can help comprehensively understanding the periodic trends in solar activity and global climate change. We hope you got something out of today's conclusion. We'll leave a link in the description so you can check the entire paper out for yourself. We'll talk soon.